Why does your brain care more about some groups of people than others? Why do we so naturally form in-groups and out-groups? And what does any of that have to do with George W. Bush's political commercials, or the Greeks, or psychopaths, or Syndrome E, or propaganda posters and how to develop immunity against them? Welcome to Inner Cosmos with me, David Eagleman. I'm a neuroscientist and an author at Stanford, and in these episodes, we sail into our 3-pound universe to understand why and how our lives look the way they do. Today, we're going to talk about why we're so wired to have in-groups and out-groups, and what the consequences are, and how some knowledge on this goes a long way to making us a little smarter in the face of propaganda. This is a topic of enormous importance, in no small part because repeatedly throughout history, groups of people have inflicted violence on other members of their population. Think of the Nazis and their killing of millions of people, Jewish communities and gypsies and others based on religious and ethnic and political affiliations. Or look at the Nanking Massacre in 1937 when the Japanese invaded China and killed hundreds of thousands of unarmed civilians and systematically raped between 80 and 100,000 people. And in 1915, there was a systematic killing of the Armenian population by the Ottoman Empire. It's estimated that about 1 million Armenians were killed during this. And then in 1994, in a period of 100 days, the Hutu in Rwanda killed 800,000 Tutsi. And this was accomplished mostly with machetes. And at the peak of this, they were actually achieving a higher killing rate with machetes than the Nazis had accomplished with gas chambers. And so the question is, what is going on here? We see this kind of thing over and over in history. And often people will inflict this kind of violence in coordination with the authorities and against groups of people in their society that were no direct threat to them and were defenseless. So how can we understand this characteristic of human behavior? Because it's of deep importance for us to understand this if we want to have any hope of preventing this in the future. Now, historians look for explanations by digging into issues of political and civil strife and economic troubles. But the real issue is that the only way these events can happen is when there's a distinct change in the behavior of individuals. And how can we understand that change in behavior? What I want to talk about today is the science of what we understand about that, about genocide. I want to put together a new framework to see how we can come to understand events like this. And I'm going to end by saying what we can do about it. So let's start in the distant past. When we think about human evolution, the story we all know about Darwinian evolution is that it's survival of the fittest, right? You have to be a strong competitor to survive and thrive. And that's a pretty good framework, but people started realizing there was a little bit of a problem because the issue is altruism. That is, when you give your own resources to help other people. How does the basic Darwinian story of survival of the fittest explain why people help each other out? You can't understand that just by thinking about individual selection. And that got people thinking about kin selection. So you may have heard of this notion of the selfish gene. The idea is that if I share some genetic material with my brother, then maybe that explains why I want to help him out. The genes want to survive. And I share a little bit less genetic material with my cousins, and so I'll sacrifice for them, but maybe a little bit less so. And so on through my family tree. The evolutionary biologist J.S. Haldane famously said, "I would gladly jump in a river to save 2 of my brothers or 8 of my cousins." So this is known as kin selection rather than individual selection. But it turns out even that's not enough to explain the world of humans because, in fact, what distinguishes our species is that humans get together and cooperate irrespective of kinship. So that led people to think about group selection, which is to say, if you and your fellow tribe members are the type who cooperate, then as a group, you all increase your chances of survival. Your tribe has a better chance of surviving than the other tribe on the other side of the mountain who are not very cooperative with each other, no matter how strong they may be as individuals. So the term for this is eusociality. Eu meaning good or positive. So if a species is eusocial, then there's this glue that allows them to build tribes and groups and nations irrespective of kinship. My colleague Jonathan Haidt gave a nice analogy for this. He said, as a result of the evolutionary history of humans, we're sort of 90% primate and 10% honeybee. By primates, he means we're mostly about individual competition, but by honeybee, he means sometimes we work together for the good of the hive. So our strong eusocial nature can't be explained just by individual selection, but instead it seems to require this selection for groups who want to work with one another. Now, this massively social nature is what underlies our ability to build and operate cities and industry and do science and so on. Humans say, hey, let's link arms and cooperate with one another and drive things forward together and enjoy all the benefits of that. This kind of thinking allows organisms to operate as superorganisms. And by the way, I should just note something about religion here. Some scholars compare religion to a pathological virus that spreads across minds, but that's probably not the optimal way to think about it. From an evolutionary point of view, things are judged by what they cause people to do. And what religions cause is for people to group together, to be eusocial. So what happens with religions is you define a group, you coordinate the behavior of the group, and you incentivize the group to cooperate and work together. So as one evolutionary biologist in the late 1800s said, religion is just another weapon in the Darwinian struggle for survival. In other words, if religion were maladaptive, it would have gone away, but it usually is adaptive in the sense that it causes groups to come together and work cooperatively. But one of the costs of our eusociality is that we get ingroups and outgroups. And today, we're going to see what all of this has to do with the brain. Historically, traditionally, we've always studied the brain by looking at individual parts and regions of it. So you say, okay, well, this is how vision works, and this is how hearing works, and this is how decision-making works, and so on. And it's only in recent years that people began to appreciate that a lot of the circuitry of the brain has to do with this eusociality. A lot of it has to do with how you interact with other brains in terms of trust and reputation and allegiances. And I talked a little bit about this in a previous episode. And this has led to a new field called social neuroscience, which studies this sort of thing. And that's what I'm going to tell you about today, and how social neuroscience can shed light on group behavior. So I mentioned in this previous episode about this philosophical problem called the trolley dilemma. And just as a reminder, there's a trolley barreling down the tracks at full speed. Its brakes are broken, and you see there are 5 workmen farther down the track, and they're going to get killed. The trolley is going to run over them. But it just so happens that you notice you're standing next to a lever that can switch the track for the trolley. And on this other track, you see there's only 1 workman there. So the question is, will you switch the track over so it kills only 1 person instead of 5? So think about what you would do here. Now here's scenario number 2. It's the same thing. The trolley is barreling down the track. You see the 5 workmen, they're going to get killed. But this time you're standing on a little footbridge over the tracks, and you realize that there is a man standing in front of you. And if you push him over the edge of the tracks, his weight will be sufficient to stop the trolley and save the 5 men. So the question is, do you push the man or not? Now, in most cases, people will not do it. But the thing to notice is that it's exactly the same question in both cases. Will you trade one life for 5 lives or won't you? Most people will do that in the first case, but they won't in the second case, which is interesting, right? It's the same math. So my colleagues Joshua Green and Jonathan Cohen got interested in this question some years ago, and they did neuroimaging on people. They put them in the brain scanner while they had the people walking through the trolley dilemma problem. And essentially what they found is there are areas of your brain that are involved in math problems that are saying, okay, well, 1 versus 5 and so on. They make a calculation. And you have other areas of your brain that care about emotional issues. They're simulating situations and assessing how those make you feel. Those areas are generally along the midline of the brain, if you drew a line from your nose to the back of your head. And it turns out that in this second scenario, where you're asking if you're going to push the guy, these emotional areas come online, and that changes your decision-making. In other words, emotions, how you feel about something, is a very important part in navigating the decision. The first scenario is just an easy math problem. The second one is an emotional problem, and it changes what you decide. And in fact, the idea that reason and emotion are fighting with each other, that's a very old idea. The Greeks had this metaphor that life is as though you are a charioteer and you're being pulled along by the white horse of reason and the black horse of passion. And they're always trying to pull you off in opposite directions. And your job as the charioteer is to stay down the middle of the road. And it's not easy, right? Because you've got these 2 different pulls going on all the time. So, emotions are tightly involved in decision-making. They serve an important role in how we navigate our lives. And you wouldn't want to live in a world where everybody is like Mr. Spock in Star Trek and doesn't have emotions, right? Because everybody would just push the man off the bridge and that would be the end of it. But instead, we use emotions to steer the decisions we make. And if something feels wrong, we try not to do it. So the question is, how do we understand or interpret the things that we see during wartime? There's a horrifying photograph from World War II where there's a crying mother who's clutching her small child to her chest. And there's a German soldier about 6 feet behind her with his rifle poised, aimed at her head, ready to execute her while she's holding her baby in her arms. Now, there are several things to note about this photograph. First, the fact that he's doing this in front of someone, in front of the cameraman, suggests that he has a diminished emotional reactivity to the situation. He's not distressed by the situation. He's not feeling like you felt when you thought about pushing the man off the bridge. Now, if this were the one guy committing atrocities during wartime, we might just write him off as a psychopath. But there were hundreds of thousands of young men doing awful stuff everywhere you looked, including running the concentration camps or raping women in the towns or lining up dozens of people along ditches and machine gunning them. So it wasn't just one psychopath. What was going on here? The neurosurgeon Yitzhak Fried in the late 90s started thinking about this question a lot. And he said, you know, when you look across all these different events in the world, you find this kind of behavior everywhere. People seem to lose their normal way that their brain functions, and they become different in how they make decisions. They act differently than they would under normal circumstances. And he said, when you look at the signs and the symptoms of their behavior, it's like there's a medical condition going on here. So he named this Syndrome E. And he said, there are very particular signs and symptoms that you look for here, just like you would look for coughing or fever with pneumonia. You look for particular things that characterize people's behavior during wartime. First, there's diminished emotional reactivity. That gives people this ability to do repetitive acts of violence. Maybe people start off having a little bit of a hard time with it, but they rapidly desensitize. It doesn't bother them anymore. Second, he noticed there's a hyperarousal, or as the Germans called it, Rausch, which is this feeling of elation when committing these horrific acts. Another sign is group contagion, which is an important one that I'll come back to. The issue is everybody's doing something and it catches on and it spreads. He also pointed to compartmentalization. Someone can care about their own family and yet at the same time do this sort of thing to another family. So these are the signs of Syndrome E: diminished emotional reactivity, repetitive acts of violence, hyperarousal, group contagion, compartmentalization. And the interesting thing from a neuroscience point of view is that the other functions of the brain are working just fine. Things like language and memory and problem solving, those are completely intact. So that gives us a clue into what's happening under the hood. And what's happening in the case of Syndrome E is something like this. The emotional networks of the brain are short-circuited. They are not participating in the decision-making anymore. They are now sidelined. They're out of the equation. So that allows a soldier to execute a woman clutching her baby, just like it would allow you to push the man off the bridge without really thinking twice about it. In other words, their decision-making is being steered by parts of the brain that can do logic and reasoning and memory and so on, but not the parts of the brain that normally navigate things with emotion. And what this leads to is a moral disengagement. A person becomes like a car that's in neutral going down the hill. He doesn't have all these systems anymore that tell him the right way to steer his actions. Now, can this sort of thing be studied in the laboratory? Yes, it can. So consider this study. People are shown photographs of other people, and you measure what's going on in their brain. And what the researchers found is that if you show participants pictures of people they admire, Olympic athletes and hard workers and so on, various parts of the brain light up. And the area I want to draw attention to is a part along the brain's midline called the medial prefrontal cortex. The medial prefrontal cortex is involved in these emotional systems, and it's also involved in social cognition. In other words, this area is active whenever you're dealing with another person, as opposed to an object like a coffee cup or a laptop. Even if you show participants photographs of people they don't like very much, like people they envy or people they pity, you still get medial prefrontal cortex activation. In other words, people still see them as humans, even though they're maybe not in their in-group. But if you go even further along the spectrum of outgroups and show pictures of people that they feel very separated from, like homeless people or drug addicts, the medial prefrontal cortex turns off. It just doesn't come online in the same way. And what that means is that they're viewing these people the same way that they do objects. So again, when you view objects, this area doesn't come online, and it comes online when you're looking at humans, except for really outgroup humans, when it simply doesn't activate anymore. So when we talk about dehumanization, what we're really talking about are regions of the brain that think about other humans that don't come online anymore. These regions are now out of the equation. And in this scenario, when you are making moral decisions about people who are in your outgroup, you don't have these eusocial mechanisms steering your behavior. With psychopaths, by the way, there are many subtle differences in their brains, but one of the issues you see is this. They just don't have these areas like the medial prefrontal cortex emotionally steering their behavior. And so they're capable of doing things like violence and murder because they don't care about you. They're not simulating what it is like to be you. They don't have the emotional feeling that's steering around their decisions. And this is what happens when groups dehumanize their neighbors. I have a photograph of a group of German citizens and soldiers at the beginning of World War II making their Jewish neighbors scrub the pavement with toothbrushes. And the Germans watching are having a great time posing and laughing. And what's happening is that because of the social context that allows Syndrome E, these emotional regions are no longer online. And so their neighbors are not like humans to them anymore. And this situation typifies genocides. Here's a quotation from a Japanese general talking about his behavior during the invasion of China. He explained his soldiers' behavior by saying it was, quote, because we thought of them as things, not as people like us, end quote. Here's a statement from a woman in Rwanda who orchestrated the killing of thousands of Tutsi. She said, quote, we thought of them as nothing more than insects or cockroaches. Here's a quotation from an American sergeant stationed in Iraq. He says, quote, you just sort of tried to block out the fact that they're human beings and you see them as enemies. So what we're talking about here is the same neural issue across place and time. Dehumanization is about turning off the parts of your brain that allow you to understand what it is like to be someone else. You may remember Anders Breivik, the Norwegian who murdered 77 young people in 2011. So back in 2012, I was following his trial closely, and here's what he said. One might say I was quite normal in 2006 when I started training, when I commenced de-emotionalizing. He said, I've had a dehumanization strategy towards those I considered valid targets so I could come to the point of killing them. He nailed it here. He knew that his own training regime was about de-emotionalizing. I mean, he phrased exactly what we've been talking about here so far. He worked, for example, with meditation to hammer away any emotional response he had to the idea of killing someone. That's the way he trained. He worked to diminish the response of his medial prefrontal cortex and other areas in the networks involved in emotion. Now, we might lament the fact that these programs are able to be overridden, but we should be thankful for the fact that they're so difficult to override, that an act like Breivik's is extremely rare, despite the logical ease of anyone pulling it off. Now, if you're not that good at turning off your own medial prefrontal cortex, you should know that there are always groups that are willing to do this for you. And that is the art and science of propaganda. So something that I have always found amazing is looking at war posters. For example, I have an American poster from World War I. It shows a giant, crazy-looking ape wearing a German helmet, and on the helmet it reads, militarism. And in one hand, the ape is carrying a huge club, and in the other arm, he's holding a beautiful woman whose arms are flung over her head. And the poster reads, destroy this mad brute, enlist U.S. Army. Now, I want to point out that if you look at any propaganda poster from any war, at any time, on any side, you'll see a common theme. You make your enemy less than human, and making them explicitly an animal is a very popular choice. So in this case, the Germans are portrayed as a bellicose ape coming onto American shores. And the fact that he's stealing away a half-naked, beautiful American woman makes you even more mad about the whole thing. And this is typical of propaganda posters. You always give the enemy fangs and feral features. And the idea is you want to shut off the networks that are involved in humanization. You want your population to feel like, we can do this. We can go to war with these guys because they're not like us. They're animals. Or consider this other propaganda poster I have from Germany during World War II, which represents America as a giant mechanical robot monster toting guns and bombs and destroying Europe. So it doesn't have to be animals, just anything that's not human. And in fact, when Darwinian thinking got introduced in the 1800s, lots of people took the opportunity to generate pseudoscience, suggesting that whoever their enemy was, they were less than human. This is a typical strategy to implement, and it can even be done subtly. Some of you may remember that when George W. Bush was running for president against Al Gore, he did the same thing. His commercial ran and said, the Gore prescription plan. And then you see this big word, rats, on the screen. And then after about half a second, as the word zooms out, you see it actually says bureaucrats. And eventually, when it's all zoomed out, it says bureaucrats decide. But what it starts with is this giant word, rats. The strategy of dehumanization is one that people use to make your brain feel like it doesn't have to think about the other person as a fellow human. And I have a lot of goals with this podcast, but one of them is to expose the simple neural tricks that have been employed forever so that you can know what to watch for. I'll come back to this at the end, but the thing I want you to keep an eye out for as you move forward is, when is someone using the technique of trying to manipulate your assessment about some other group by making them less than human, like animals or machines or viruses or insects? Once you start seeing the tricks of propaganda, you'll find yourself more immune to them. So how does the issue of dehumanization get studied in the laboratory? Well, in 1975, a researcher named Albert Bandura set up a simple study. He had college students come in to do an experiment. So you come into a room and you're told that in this other room are 3 college students, and they're trying to learn some associations with words. And you're there to help teach them. Whenever they get a wrong answer, you are to send an electrical shock to them in the other room. But you get to choose how high the level of that shock is from 1 to 10, and you get to choose each time they make a mistake. So those are the rules of the game. And what happens is, just before the experiment starts, the experimenter running it accidentally leaves the intercom on, and you overhear him say, "These guys," meaning the students that you don't see, "these guys are a bunch of animals." Or in a different condition, he says, "Oh, those guys are really nice." Or in a third condition, he doesn't say anything at all. So that's it. The only experimental variable is what you overhear him say. So the experiment begins, and every time they get a wrong answer, you get to decide between 1 and 10 what level of electrical shock you're going to send. And what Bandura found was striking. In the dehumanized condition, where they're called animals, people send stronger shocks, the only difference being that they heard them described as animals at the beginning. In the neutral condition, where nothing is overheard, they send milder shocks. And in the humanized condition, where they overheard the compliment that they were nice, they sent even smaller shocks on average, just by dint of having heard a simple sentence that humanized them. So I want to be clear that the issue of humanization is not something that's just turned on or off. It's more subtle. It's not just human or non-human. Your notion of what you think about someone can be modulated quite subtly. And this is one of the things we've studied in my laboratory. So for me to explain this, let's talk for a second about pain. Let's say you put your hand on the table and I stab your hand with a syringe needle. That activates a particular series of areas in your brain, a network that we summarize as the pain matrix. And that network says, "Ouch, I'm feeling pain." Now, if you watch somebody else's hand get stabbed, it's not your hand, you're watching a video of someone else's hand get stabbed with a syringe needle, what happens in the brain? Most of this same network becomes active. So these areas respond when you're in pain or when you're watching somebody else in pain. And this is the neural basis of empathy, watching someone else in pain and simulating what it is like for them. You're running a simulation as if it were your hand. That's what empathy is. You're literally simulating what it is like to be the other person. Now, the surprise is, even though this is a very low-level neural response, it can be modulated by what you think about the other person. So there was an experiment done by my colleague Tanya Singer, in which she had people play a little game with other people where they're making decisions about exchanging money with each other, what's called an economic decision game. I'll skip the details. The important part is that the other person that you're playing with is a shill, someone who's secretly working with the experimenter. And they can either play fairly or unfairly. So you're either playing with someone who you feel does the right thing or against a person that you conclude is a bit of a cheat. And then you get to see the person get an electrical shock. Now the question is, how much does your brain care? Just based on their behavior, whether they're fair or a cheater, your empathy can be modulated. You care more or less about their pain. Now, I'll link to all these papers on eagleman.com/podcast, but I'll just mention there are a lot of individual differences between the participants. And on average, men showed this effect of losing their empathy more than women did. But once again, the point is that this very basic neural response about seeing someone else in pain can get modulated. Now, this is based on their behavior. And one of the things that I started wondering about in my work was, could this be based on something that's not even behavior? You never even meet the person, you never see the person, but it's just based on the in-group or out-group that they're in. Could that modulate empathy? So my student Dawn Vaughn and I put people into the brain scanner, and we show you 6 hands on the screen. Then on each round, the computer goes around and randomly picks one of those hands, and that hand expands to the middle of the screen, and then you see that hand get touched with a Q-tip or stabbed with a syringe needle. We contrast those two conditions to find those areas of the brain that are just involved in that difference. And as I mentioned before, this is where we find a network that we summarize as the pain matrix. Now that we've established this baseline condition, we just make one very simple change, which is now we label the 6 hands on the screen with a one-word label: Christian, Jewish, atheist, Muslim, Hindu, Scientologist. A hand gets selected, comes to the middle of the screen, and then you either see it get touched with a Q-tip or stabbed. And the question is, what's your in-group, and how does your brain respond to seeing that hand get hurt, as opposed to one of the other hands get hurt? So in the baseline case where there's no label, your brain shows a lot of activity in this network. This is the empathic response. When you watch your in-group get stabbed, you see this response, but larger. Your brain really cares about your in-group in pain. And when you watch a hand labeled as one of your out-groups get stabbed, the response is diminished. So you care a lot about your in-group and less about your out-groups. And by the way, we recruited participants of all different religions, and we see this same in-group, out-group effect for everyone. And by the way, of interest is that we see the same effect even for the atheists. Atheists care when they see an atheist hand get stabbed, and they don't care as much when they see someone else's hand get stabbed. So this is a very basic issue about labels. It's about whose team you're on. Now, something that got me interested is understanding how flexible these sorts of designations are. So if you look, for example, before World War II, the Americans and the Soviets hated each other. And then during World War II, they were both allied against the Axis powers. So now they were buddies and fighting side by side. And when the war ended, they went back to a position of enmity. And I thought it's interesting how flexible labels are. So we did the same experiment. We put you in the scanner, and now it says the year is 2032, and 3 of these religions have teamed up against the other 3 religions, and it's randomly selected every time. Okay, so now you're in the scanner and you see the 6 hands on the screen, but now you have teammates, allies. These other religions that you didn't care about a minute ago, now they're on your team. And the question is, what happens when you see someone else's hand get stabbed if they're an in-group but happen to be an ally? And the answer is, we find particular regions in the brain that are sensitive to these alliances, which is to say, 5 minutes ago, you didn't care at all about this outgroup. And now just because we've told you in a single sentence narrative that this outgroup is on your team, now you care a little more about them when you see them get stabbed. So even though labels like religious labels run so deep, things are flexible. And that got me interested in a third phase of the experiment to really understand about the arbitrariness of labels. So what we do is we have you come into the lab and I hand you a coin and I say, you're going to toss this coin. And if it's heads, you're an Augustinian. If it's tails, you're a Justinian. That's all I tell you. I don't tell you anything else. So you toss the coin. Let's say you're a Justinian. So I now hand you a bracelet according to which team you're on, and you put it on and you go into the scanner. And we give you a one-sentence narrative that the Justinians and Augustinians are 2 warring tribes. And it's the same thing. The computer chooses a hand and you either see the Justinian hand get stabbed or the Augustinian hand get stabbed. And the question is, does your brain care more about a team that you were arbitrarily assigned to? And you know it was arbitrary because you're the one who flipped the coin. And the answer is yes. It's a smaller effect, but a totally arbitrary team label is sufficient to make you care more for your in-group. And this is at a very low level. This is a very basic neural response. So this is the kind of thing we've been studying. And it's important not only for what it reveals about human nature, but also because it gives us a diagnostic tool for measuring the degree of in-group, out-group. In other words, how much do you care about your in-group and how much do you not care about your out-group? We can quantify that difference, and that gives us a tool into the future to measure the effect of rehumanizing narratives. In other words, what are the different interventional strategies that we can use to actually make groups reconverge? So we'll come back to that in next week's episode. What I've told you about today is the issue of dehumanization and how your brain dials up and down the degree to which you view another person as human. And in next week's episode, part 2, I'm going to expand these points to dive deeper into our brains to understand what we can do about it. I've said this before, but I want to be really clear about this point. The reason we work to understand the science of human behavior is because our psychology has been carved by millions of years of evolutionary pressures. And what we see in history is the same events playing out over and over again, wherein groups of individuals turn on their neighbors and devour them. And this is not academic stuff that makes no difference. This is the most important work that we can devote ourselves to understanding. Because as we come to understand the details of our psychology and the tools of propaganda, we develop our capacity to at least recognize when we are getting manipulated. So when a government or a rebel group or your neighbor tells you something about the members of some other country or some other religion or some other group, we can at least be a step ahead of our predecessors in previous generations who fell for the most basic tricks over and over. We can work to strengthen our societies and improve our world by better understanding the fabric of our own psyches. Go to eagleman.com/podcast for more information and further readings. Send me an email at podcast@eagleman.com with questions or any discussions, and I'll be making an episode soon in which I address those. Until next time, I'm David Eagleman, and this is Inner Cosmos.